Good evening. I want to take you through a data analysis project in R. And basically, we are going to look at one of the rides hailing company called Uber. And basically, what we are going to do is that we are going to see how we can analyze data using R. So I have the data set already in my computer, but also I'm going to put a link of the same data set in the YouTube channel so that you are in a position to download and practice during your own time. So let me just put a title for this project. This project is called Uber Data. Sorry, this is Uber Data Analysis through visualization in R. And one assumption that I'm making while recording this video is that you are already or you already have basic knowledge in R and also majority of the tools that you are going to use and so on. So the first thing is for us to import this data set. That is the first step that we are going to take in this project. And to import this data set, first of all, I need to know uh, my working directory in R. So I want to ensure that where my data set is stored is the same place as my working directory. So I'm going to use the get working directory function to know my working directory. So currently my working directory is users 104G3 documents. I want to change it uh, uh, to enable it to be in where my data set is. I can use set working directory, or to make life easier, because I'm working in R, I'm working in R Studio, I can just go to session, then set working directory, then choose directory, click choose directory. I want my working directory to be in my desktop, and more specifically, I created a folder for Uber project, then I click open. So you see, this is my working directory now that I'm going to be using to import uh, my data into R. So to import our data, you see, this is the data set in my desktop. The data set that we want to import is in this folder called Uber project. And they are for 6 months, April data, August data, July up to September. And I'm going to import it in a form of a .csv file. So first of all, you must ensure that your file is saved with an extension of .csv in Excel. So in some of the laptops or Excel versions, this .csv might not appear here, but it is already saved. So I need to import these data sets individual, then we are going to combine. So I can say importing data set. So I just want us to start with the April one. So I'm going to say April, create a data frame object called April, then assign. Then we are going to use read.csv, the first one. Then the easiest way to do so, I'm just going to copy this in the setting working directory. I'm going to copy this directory with the quotation marks, of course, and paste here. So, but now I'm interested. My first data set is called April underscore data. So I'm going to type April, so not underscore. Yeah, it is April underscore data. But now I want to import as a .csv, so I'm going to add a file extension of .csv, which stands for comma delimited. So having imported that, I can execute it. Yeah, that one has already been imported. Then for the rest, instead of typing this code once more, maybe again, I'm just going to be copy pasting the code and doing some kind of what editing. So I'm going to put the one for May, read.csv, where there's April underscore data. I'm just going to see how the May data has been stored, which is May underscore data. So I'm just going to edit April with May. Everything else remains the same. I run it or I execute it. It is importing because you see the red button. I'm proceeding the same. After May, we go to June. How is June stored? June is stored at June underscore data. So June underscore data, I execute it. The next one is July. Sorry, we just paste first of all, then we come up with a variable called July. Oh, maybe one thing to clarify, these variables you can even give your name. April, your name, May, and so on. So for July, also just change this. Then the next, I think, is August. August, how is it stored? So you see, you don't need to write all the codes again. You just copy paste and edit. Uh, the last one was September. So I'm going to September. Yeah, all have been imported as individual. So the next thing, I want us to combine all these data frames into one. And let us come up with one data frame called, we can call it maybe combined underscore data. Then the combined data, we are going to combine uh, uh, them together in R. And of course, we are going to combine by row. Therefore, we are going to use R bind. Then you just set the name of what? Our data frames. We have April, we have May, we have June, July, August, September. And remember that R is case sensitive, so you must ensure that Your spellings are okay, so I can execute my. Okay, object September not found. That's what I was saying. Yeah, because I had not executed September here, let me run it first. That's why it was not found there, because I had not executed that line of code. Yeah, so I think now I can execute line number 14. So again, object sept, because I need to put September in full. Sorry for that once more. Yeah, it is now executing. So I have combined my data set. I can view it and see it is called combined. So this is a combined data set. It has variables date.time, latitude, longitude, and base. Maybe also we can look at the structure by using the str function. You can look at the structure of a data set, combined data. Good. So we see it is a data frame with 4.5 million observations and 4 variables. It has the date, time, latitude, longitude, and base as the variables, whereby the base is character, longitude and latitude numerical, date or time. Of course, in R normal, when you import it, it comes as a character. And we are going to see how we can now convert it into dates. So we have finished the first step. The next thing is that we need to import libraries. And we say that libraries in R are just assist R to with a lot of functionality. So I can say the next step is importing necessary libraries. So before we import, I just want to highlight those libraries and what they are used for. The first one is ggplot2. Why do we need it? So uh, used for data visualization. Oh, I need to put also a comment. Used for data visualization. That's the main purpose of ggplot2, used for data visualization in R. The next one is LabRedet. Mostly if you want to use time frames in our data set, because our data, as we have seen, it has some time, so we need to do some manipulation later. Then we have the dplyr. The main purpose is to tidy the data. We have another one, dt. Are mostly used for, that is for data tables in JavaScript, JS. Then the last one we have what called scales. It is also a library in R. Used to map the data at the correct scales with well-placed axes automatically. So these are the main data science libraries in R. So the next thing now we have, first of all, to install the libraries. So this installation, of course, is what we call importing. And before we use, we will load them. So to install, I'm going to use the install dot packages function. The first one is ggplot2. When installing a library, ensure your laptop is connected to the internet. So it is still installing. It depends also with the speed of your internet. So it depends. It sometimes takes quite some time. Still installing. So that library has been installed, that package rather. In Python, we call them libraries. The next one is gg themes. Can install that one as well. Okay, that one is also installed. The next one, we have quite some packages. It's LabRedet. Sorry, it's LabRedet. You have always, when installing library, you have to put it in a double quotation marks. When you install it at first, R treats it as a string. The next one is dplyr. After dplyr, we are going to install tidyr. The next one, we are going to install a package or a library called tidyverse. And I can add a comment by saying that it is a meta package of all tidyverse packages. So we are remaining to install two more, that's dt and scales. So it depends also with how heavy the package is. Tidyverse is a very heavy package because it contains other several packages. So you see it has a lot of several packages. So that's them. The next one is dt. Okay. The last one, of course, is scales. Yeah, so all our libraries have been installed. The next thing is now to load. Remember, in R we install the packages or libraries once, but whenever we want to use them, we load. Loading packages. So I want us to do a simple thing. First of all, let us copy all these. Copy, we paste here. Before even we load the packages, I want us to remember in R you install the package once, but whenever you want to use it, you load it. So it means I have to keep on loading, but since I have installed these, I have to put them as comments so that I don't make a mistake to reinstall them again, which can make my Arc to restart, Arc Studio to restart when I don't want it. Remember, we are using Arc Studio, which is the integrated development environment for Arc GUI, and GUI stands for Graphic User Interface. So the next thing now, because you want to load the libraries or the packages, we use the library function. And the packages now given that we have installed, you don't need to put them in quotation marks. That one is done. Next one is GG themes. Type library, remove the double quotation and execute. We have the lab relate. That is done. Then the dplyr, then we have the tidyr, then tidyverse, okay. Then we have the dt. So we have a lot of libraries, and every library has its own function or package. So the last one is scales. Remember, we are typing in the script window, and we can see the output in the console window. The console window is this one down. The script or editor window is the one on the top. Yeah. So we are done with that step. The next step is that we are going to create a vector of colors that we will use in our visualization. Creating vector of colors for the plots. Okay, basically we are going to use the color codes, but if you want to know what the color codes mean, you can just go online and search color codes. You will be able to see. So I'm going to call this vector color. And remember we said that when you learn about vectors, creating vectors, you can create using the concatenate function. So the first one, hashtag capital CC 10, 11. The second one is hashtag 665555. The third one, the third one is 05 A 399. So uh, 399. The next one again is hashtag CF CACA. Then another one, color code F5E 840. Another one is 0683 C9. It must start with a hashtag. The last one is hashtag E07 5B 0. So this is a vector of colors that we are going to use in our plot. We can execute this line of code. Of course, in R you can, especially when we are working on the script window, you can just type and highlight once and execute if you want. So the next section now, remember that the date.time column, let us just have a view of our data set that we combine. We called it what? The data set we combined, we called it combined data. Yeah, this one, combined data, using the head function, which will allow us just to see the first 6 rows. You see it has date.time, latitude, longitude, and base. As we were looking at the structure of this data, we saw that date is a text, so we need to convert them. So we want to format the date.time into a more readable format using the date-time conversion function. And this is found in what? Uh, in the library that package. The next step I can say, we want to format date.time variable into a readable format. Of course, you are going to use functions in library date package. So the first one, in our data set called combined data, we are going to subset. To subset, we use the $sign, the date.time. So we are going to use a function called as dot for CT tab rather. Then the name of our data set is combined data. Then we are interested in this date.time. We want to format it. Let me just try to format to be equal to month, day, year. Of course, here like in full, like 2022 and so on. We have hours, minutes, seconds. I think that is fine. Yeah. So basically, we might not see the change, but we were trying to format our date into month, day, year, hours, seconds format. So it is executing because it is a large data set. That's why it is taking quite some time. So it is taking quite some time. We have to be a bit patient. So basically we have managed to format it. So I want us again to come up with another column in our data set called combined data. You want to use the $sign to add a new column called time. And this new column called time, we are going to format it. We're going to format it. The name of our data set is combined. So it is not combined variable. Sorry. It is the name of our data frame. Yeah, combined data, $sign. You want to apply it to the date.time. Comma format. The rest, this section, I'm just going to copy. I'm just going to copy it from here to make my life easier. Copy, paste. Then, comma. Remember the commas that in R, arguments are normally separated by commas. So don't be surprised why we have them. In fact, this comma is for this line number 56. I can put enter so that my line of code is not so long. So I can comma. I can close this one here first. Then this one. Again, I say format be equal to hours, minutes, and seconds. This one, I just pick up to here, copy. The beauty of copy pasting, it minimizes errors. So I can highlight this line of code and execute it. So a new variable called time is going to be added to our data frame. And that new variable is going to contain time in hours, minutes, and seconds, as you are going to see. Okay, so we can use the head function and see what has happened. Sorry, head apply to our data set called combine underscore data. A new variable, you can see a new variable called time has been added in the format of what? Hours, minutes, and seconds, which was not there initially. The next thing we are going to do, we want to convert our date.time into a variable, into a universal kind of time frame. So again, I'm going to say combined data. I want to apply it to the date.time. To do the conversion, we use the function ym. We use the ym-hms. That's the function we are going to use. Then we are going to apply to our data set called combined, again, data, then to the variable called date.time. Then we execute it. So it is executing. So the next thing we want to do is to create individual columns of variables for month, day, and year. For month, day, and year. We are going to start with the day. So in our data set called combined data, we're going to add a new variable called day. Day is a factor, of course. Then we use the day function, and we apply it in our data set called combined data. And more specifically, we are going to apply to the date.time. Then we execute. The next one is month. So I'm just going to copy this code and do some editing to make my life easier. So we are going to add month. Month is also a factor. Where we have day, we put month. But with month, I need us to put another argument. And this argument is called label. You say is equals to true, so that the months are labeled. That's done. The next is year. So I'm just going to copy. Where there's day, I put year. Then where this day again, I put year. The first year is a variable that we are adding. The second one is a function for extracting year from our combined data, and more specifically the date.time variable. Same applies to day and month. Yeah. The last one You want day of the week, day of week. Of course, is also a factor. To come up with it, we use the function wday. And of course, we want to label like Monday, Tuesday, and so on. We say label to be equal to true. So we can execute. So we have looked at the month, day, and year variables. We want us to add the time variables. The first one, we are going to add a second in our data set called combined data. We are going to add a variable called second, and this variable called second, of course, it should also be a factor. And then we use function second to extract it. And we are extracting it from where? From our combined data. But this time round, we are extracting it from this column that we added called time. That's where we are extracting it from. So let me check in case date, combined data second, factor second. So let me check our data set. Yeah, it is fine. So the next one, I'm just going to be copying and doing some editing. You look at minute. Where the second we put minute. So the last one, we are looking at hour. So I'm going to edit second and put hour and execute it. So we want to have a final look at our data using the head function, combined data. Date, latitude, longitude. So you see a data set that we had only 4 variables. Currently, there are more. So that is what we have managed to do. So the next thing or step is data visualization. So we want first of all to plot the trips by hours in a day. So we can come up with a data set called hourly data. Um, so in our data set called combined data, I'm going to introduce what we call uh, a pipe function. A pipe function is used to connect like more than 2 operations in R. So like hourly data is just a variable that you can put your name, but combined underscore data is the name of our data set. Then you put the pipe function, enter. Of course, we just do so to ensure that our lines are brief for easy readability. So I want us to apply the dplyr package. Instead of loading it, you can use dplyr double full colon. I want us to apply the summarize function. Sorry, summarize the summarize function. We are interested in total to be equals to so we can execute it. Then we can use the function data table and apply to our hourly data set that we have formed. So you see the output in this window. Sorry, here I can zoom. So you can see. So the next thing now, after coming up with that summary, I want us to plot the data by hour. To do so, always we start with the ggplot function that is found in ggplot2. Then we apply to our data a new data set, a summarized one that we have come up with called hourly data, comma. Of course, we put the aesthetic. Aesthetic is how we want our data, like the visual aspects of it, is the hour. Remember, we came up with a variable called hour, and total, of course, as formed in our aesthetic, in our when I apply the summarize function. So plus, meaning that I want to continue with this line of code. So geom is how you want your data to be represented. So for us, we want a bar plot. So start, I want us to use identity. fill to be equals to still blue. Then color to be equals to red. Then we apply another. I want us to input the title by using the ggtitle function. The title should be trips every hour. In the subtitle, I can use aggregated today. Then on the legend, I can say legend position, legend.position to be none, don't need a legend, comma, plot dot title element underscore text So we want just to see the non-components of the plot are shown by using the element underscore text. Let the height be 0.5. For the plot subtitle, to be the text element for that element height text can as well use 0.5 so that they are proportional. The Y scale, scale and Y, to be comma. Yeah, then I think we can execute. So there's an error. Let me check. So there's a mistake I made by here before the summarize. I was supposed to write. So our data combined. After this one, I'm supposed first of all to group by, yeah, I'm supposed to group by our data by hour. Of course, before now summarizing. I think that was an issue. So I can execute it. It is going to work. Run. Let us see. So you can see now our table is a bit different now. We can just zoom. So you see at 0 hours we had a total of 89,322 Uber trips. At 1 hour, at 1 a.m. we had 58,000, at 2 a.m. and so on. So that was the mistake that I had made up there. But now it means when we execute our code on visualization, yeah, it is going to give us this plot. These are total trips every hour and aggregated. You see the hour and of course the totals and so on. So we see that at 5 p.m. is when most trips they peak at 1 p.m. and also 7 a.m. there. I think when people are going for jobs and so on, that's when we have some trips. So you can use the same and do other kind of plots and so on. So basically, maybe the importance of this visualization, if I can say, is that, for instance, when you are dividing the management of Uber, it is very clear that at 5 p.m. you need to have a very stable kind of system to ensure that whenever the users say more, we have surety in terms of system stability to avoid downtime and so on. So you can as well try and do other plots in terms of comparing, plotting based on days and so on. So this is the end of this project. We have learned, first of all, importation of data. We have learned how to combine. We have loaded the libraries. We have seen how to extract dates um, from day of the week, month, and so on from a data set. As well, now we have seen how we can do the plotting and so on. So this is the end of this project. You can try as much as possible with it. Thank you so much for following up. For any questions, always reach out to us at AfriCDSA and we will be able to assist you. Thank you.